This video will show you how to use a transistor as a switch. This is a typical circuit that uses a transistor to turn a lamp on and off. When the physical switch is closed, a current IC circulates through the lamp and the transistor. The magnitude of IC depends on the base current of the transistor, IB. IB should be large enough for the transistor to enter saturation. When saturated, the transistor permits the free flow of current. In other words, it behaves like a closed switch. The base current IB is controlled by the base resistor R. We will now learn how to calculate R so that the transistor enters saturation. First, calculate the base current. This is equal to the transistor current, that is the same current that circulates through the lamp, divided by the minimum gain of the transistor. The value of minimum gain of the transistor can be found in the transistor's datasheet. The value of the base resistor will be equal to the load voltage divided by the base current. The load voltage is equal to the battery or power supply voltage minus 0.7 volts that are lost in the transistor. In order to test the circuit, I'm going to use this lamp. It's a 12-volt lamp, and the current is, let's see, 950 milliamps, or almost 1 amp. Let's calculate the value of the base resistor. First, the base current is equal to 0.95 amps divided by the minimum current gain of our transistor, that is 20. The base resistor will be equal to 11.3 volts divided by the base current. Remember that the voltage is the applied voltage 12 volts minus 0.7 volts of voltage drop through the transistor. The base resistor is then 238 ohms, and we will use the closest commercial value, that is 220 ohms. Here we have our circuit on protoboard. Let's see. The transistor is a type 31C. It's base, collector and emitter. The positive of the supply goes here, passes through the lamp, from the lamp to the transistor collector, and then emitter goes to ground or negative. Also, from the positive of the supply we go here to the switch, from the switch to the resistor, 220 ohms, and the resistor is connected to the transistor's base. Let's now test the circuit. Our power supply is set at 12 volts. The positive is here and negative at this point. Let's now test the circuit. I'm going to push the switch, and we can see the current is 995 milliamps, or almost 1 amp of current. In our circuit, we are using the same power supply for both the load and to activate the transistor. However, it is frequent to use two separate power supplies. A high power one to power the load and a low power one to activate the transistor.